Welcome to lesson 1. In this lesson, I'm going to show you how you can program the EEPROM available in the controller Atmega 328P. So first question is, what is EEPROM? You can imagine a diary page which can be compared with EEPROM, where in each line we can write data and there are number of lines in a page. Similarly, if we look inside the Atmega 328P microcontroller, we'll find there is an EEPROM which has a size of 1 KB. 1 KB means 1024 bytes. So there are 1024 lines. You can call it rows of 1024s. And columns of, there are 8 columns. In each line, we can store 8 bits of data. So the width of the page is of 8 bits and the length of the page is 1024 bytes. This is the simple EEPROM it has. So EEPROM stands for electrically erasable programmable ROM. That means these contents, if we store something inside EEPROM, we can erase it and restore the program. Like if we want to store some kind of data, we can easily store that, we can easily erase that, we can easily reload some other data too inside this EEPROM. How? Because these data can be electrically erasable. That's the benefit. So why we need an EEPROM? EEPROM is an extra storage available in this Atmega 328P controller, where we can store crucial data. Let me show you how we can apply EEPROM in our applications. Recently, I did one program with a company and they were trying to make a voltage stabilizer. So in that application, what I did is I have used a sensor where we are reading the voltage data, and the latest voltage data where some kind of contact breaks or makes, the data is getting stored inside EEPROM. So when they are trying to retrieve the data is transmitted over serial port, and that data goes to the software to generate a report. That kind of application I did using EEPROM. So suppose you are reading a temperature data coming from a sensor and you have a factor, and if you multiply that data with that factor, then you will get some meaningful data. That factor's value can be stored inside EEPROM. This is the example application I'm telling you. I'm also giving you another example of tea coffee vending machine. Once I had a chance to visit a company where they were programming this tea coffee vending machine. Whenever we use tea coffee vending machine, or you have seen somebody is using it, you have seen that there are 2-3 buttons, one for tea, one for coffee, one for normal milk, one for hot water. So these are the buttons, and there are few containers inside that machine. One container is holding coffee, one container is holding tea, one container is holding milk, one container is holding hot water. So whenever you are or somebody is pressing the coffee button, the controller is taking some amount of coffee, some amount of milk, some amount of water, and some amount of any other ingredients if it needs. Then it is mixing the all ingredients together, and it is pouring it in a cup. Then how much amount of coffee is needed, how much amount of milk is needed, how much amount of water is needed is configured by the user according to their requirements, and those configurations are stored inside EEPROM. This is the actual case. I have seen it. So what I'm trying to say is EEPROM, you can apply EEPROM programming in many applications. If you are doing a project, you can use EEPROM in that too. If you want to store something, permanently, you can use EEPROM, because when power goes off, the data is still there. So EEPROM can be used in many cases. In Arduino, there is this built-in library called EEPROM. Whenever we write a program to handle EEPROM operations, we use EEPROM.h. This is the header file, and there are two crucial functions. One is for write, another is for read. So write function, the syntax is EEPROM.write within bracket address comma val. Address can be any number, any integer number between 0 to 1024, and value can be a character. Better to use unsigned character. Unsigned character is of 8 bits, so value is of 8 bits because the width of EEPROM is 8 bits. So you can use unsigned character in case of value and an integer in case of address. Address can be represented as decimal or hexadecimal, whichever you are comfortable with, you can use that. And read is a return type function. Unlike write function, read is a return type function, and the syntax is EEPROM.read within bracket address. It will return you the character which is stored inside that address. For an example, suppose I am writing EEPROM.write within bracket 0 comma character A. So in a single quote I am writing A. That means the 0th location of EEPROM will have a data of A. Now A is a character, so what inside that 0th location will be stored is 0, the ASCII value of A. That means 0100000001. In hex this is 41. And whenever we want to read the data, simply write EEPROM.read within bracket 0. This function will return the character and you have to store that somewhere. For that, what I'll do is I'll perform an experiment where my objective is writing and reading data to and from EEPROM, and my methodology will be I'll first write a character to EEPROM and then perform the read operation. Once that operation is successfully completed, at the end I'll print that data on serial monitor. To perform this experiment, I need nothing. I need just an Arduino board and then USB cable. So there are no circuit, nothing. So I'll straight move to the code. So from now on, I'll not show you the line by line writing of the code. So what I have here is I have the program and I have already saved the program. You can see this is the program I have written. This is a simple program, just 4 or 5 lines of code. So here through this program, I'll be writing and reading data to and from EEPROM. So here I have used this library. You should use this EEPROM.h. Otherwise, no functions will get compiled. You have to include this header file. Inside void setup, I'm writing data A to memory location 0. So what I have written is EEPROM.write within bracket 0 comma A. A is a character, that's why I have denoted it in single quote. And remember, the memory location is 0. Now I have used a delay of half a second. This delay, there is no meaning to use this delay. I have used it because I am giving ample time to write data to EEPROM. Now come to void loop, where I'll be reading. So here I have defined a variable character A is equal to EEPROM.read within bracket 0. So through this statement, the controller will read the 0th location and will return the data which will eventually be stored in character A. The memory location is same 0, and there where I have written is also 0. Then I am printing the data and then delay of 5 seconds. As there are no other work to do, so I am slowing up the process by using this delay. So after every 5 seconds, the data will get printed on serial monitor. And here I have used a character type variable. So EEPROM.write and EEPROM.read. We can do the EEPROM operations successfully. Now let me compile this. I have already saved my program. Program is successfully compiled. Now Arduino is connected at COM5. Let me upload. It's getting uploaded, done uploading. Now I can open the serial monitor. See what happened? There is no data. That means something I have missed. If it happens with you, you don't need to get tensed or get worried. You have to check carefully your program. Here what I have missed is I completely forgot to initialize the baud rate. So let me write that. Serial dot begin within bracket 9600. This should be included. Otherwise there will be no serial communication. Now you understand why this statement is very important in your program whenever you are using serial communication. Let me re-upload it. It's done. Now I am opening serial monitor. See, A printed. Now after 5 seconds another A will be printed. So every time it will be showing A only because I have written that A inside void setup. So inside void setup the E square PROM write operations done. Then inside void loop we are performing only the read operation. That's why it is showing a single character A. Now I think you have understood the E square PROM interfacing and E square PROM programming. In the next lesson I'll tell you how you can interface LCD 16x2 with Arduino.